equation. First line is 2x plus 3y equals 11. Second line equals x plus 4y equals 13. So what we do is we get the second line and we times by 2 to get two like terms, which is 2x. Then we minus the first line from the second line, giving us 5y equals 15. When we then divide by 5, we get y equals 3.
Now that we know y, we can substitute it in here. Okay, so you times the 3 by 3, which will give you the 9, and then you take this over to the other side. Now when you take this over to the side, it has the opposite sign. So instead of being plus 9, it becomes negative 9. You take that away from 11, which will leave you with 2. So now you have 2x on this side and 2 on that side. What you do is you take this 2, since it's next to the x, and you divide it on this side, which will leave you with 1. X equals 1.
Right, now that we've found out our x and y values of 1 and 3, we can plot the points on a graph. So the x value here is the x-intercept, as drawn, and the y value of 3 is a y-intercept, giving us a straight line.
So here we have 3 simultaneous equations. Line 1, we've got 3x plus 3y plus 2z equals 1091. Question number 2, we've got x plus 2y plus 2z equals 596. And line 3, we have 2x plus y plus z equals 574.
Okay. So now we want to reduce this to a 2 by 2 equation. So what we're going to do is we're going to get line 1 and we're going to minus line 2 from it. So line 1, 3x plus 3y plus 2z equals 1091. X plus 2y plus 2z equals 596. When we minus this one from this one, then we get 2x plus y equals 495. This is now equation A. Then we get line 3, and we minus that from line 1. But for line 3, we're going to times it by 2 to get like terms of 2z. So line 1, 3x plus 3y plus 2z equals 1091. And line 3, 4x plus 2y plus 2z equals 1148. And then we end up with negative x plus y equals negative 57. And we're going to call this one B.
Right, now we have these two, A and B, and we subtract B from A. So we've got 2x plus y equals 495, and minus x plus y equals minus 57. If you minus those off, you're left with 3x equals 552, and divide that by 3, and your x equals 184.
Okay, now that we've got the value of x, we have to substitute x into our equation 2x plus y equals 495. So that we know, now that we know x is 184, we times that by 2, add y to it, and we'll get 495. So to expand the brackets, we get 368 plus y equals 495. Take 368 from both sides, and we're left with y equals 127. Now that we know the value of y as well, we have to substitute both x and y into another equation, giving us 2 times 184 plus 1 times 127 plus z equals 574. Expand the brackets, we're left with 368 plus 127 plus z equals 574. Subtract the sum of these two figures, which is 495, off both sides, and we're left with z equals 79.
So now you just plot points, and you've got 184x, and you've got 127y and 79z, and you just make a kind of 3D image in between them, and you're sorted.
So here we have the coordinates 30, 30, 20. We have x equals 30, y equals 30, and z equals 20. Now here's one example of a line of equations. This is one of many equations that you could use, but for this one we have line 1, x plus y plus z equals 80. Line 2, 2x plus 4y plus 3z equals 240. Line 3, 2x plus 3y plus 3z equals 210. Now the proof for it, we take line 2 and we minus from that line 3, giving us y equals 30. Then we get line 1 and we times it by 2 and we take that away from line 3, giving us y plus z equals 50, and we'll call this equation A. Now when we get equation A and we substitute in the known value for y, which is 30, we get 30 plus z equals 50. We then take away 30 from each side, giving us z equals 20. Now we get line 1 again and we substitute in our known values of 30 and 20. So we get x plus 30 plus 20 equals 80. We then take away 50 from each side and we get x equals 30. And once again our values, x equals 30, y equals 30, z equals 20.
What we have here is a geometrical representation of this set of simultaneous equations. What we have here is there's one point that all three planes will intersect, as there are infinite possibilities.
Sweet dreams are made of these. Who am I to disagree?